Alright, this is for how to make an automatic shoulder pad. So right now it does this. When it rotates above a certain point, this guy gets activated, and if he's already rotated, this thing won't rotate until it does. And the animator can just zero this out, as they would, and continue working. Alright, so first to just kick things off, I'm going to give a brief overview of the node setup, and then we can start building it on this side. So right now, it says, okay, hey skin joint, if you're rotating upward, I want you to apply that rotation to this shoulder pad constraint group. So right now I got my setup. My shoulder pad is set up underneath my clavicle, so when I move my clavicle, the shoulder pad should move as well. What this is doing is checking, hey, if it's above this amount, we got a condition node. If it's above this amount, just go ahead and throw it into this constraint group. These multiply and divide nodes in here are mostly just for my personal organization. When you're rotating this one, you'll notice that when it's up, it's negative. So I just wanted to be able to clean it up visually for myself and move it into the positive range. So essentially, if it moves in the negative range up here, it should not affect anything until we get here. That doesn't really make any sense until we get to the other part of it, which is to check if this guy has already moved. So, because I was running into some issues where making it read from the anim itself was not... Okay, so it does read from the anim itself, but when it's reapplying the rotation, it's going into a different group that is driving the joint itself and not the controller. This will avoid sort of like an input loop where I would essentially be taking the output rotate yada 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 and then throwing it back in here. Or even if it was in a constraint group behind it, it would still end up creating a loop. So, when the shoulder pad is moving upward, condition here, it's in the same direction as up here, it's in the same direction as up here. If the amount of the arm's upward rotation is less than the shoulder pad's rotation, the shoulder pad is rotated equal to the value of the arm's upward value subtracted by the shoulder pad's upward value. Which is a whole bunch of crazy math nonsense, but essentially it's saying, hey, shoulder pad, you're rotating upwards, right? Okay. If you are rotating upwards, and this guy is already rotating upwards, we have to find some sort of collision there for the two to interact. So this condition node says shoulder pad in and up. Is the shoulder pad moving up? Let's see. Since the first term is greater than the second term, because the shoulder pad is moving up, we're outputting this amount into our condition, because it's true. So we're taking that value, and we're subtracting it from the amount that the skin of arm joint has moved. So I'm subtracting this amount from here. And then another condition happens. So we're saying, if this one is moving up, throw it in here. If this condition is true and it's outputting the amount that the skin joint is moving upward, compare it to the amount that the shoulder pad anim is moving. If the second term is less than or equal, if the first term is less than or equal to the second term, then we're outputting the amount that we subtracted from the conditions. This output is given to an off group. So while the math side takes care of all the weird conditions and all that good stuff, I can see that my shoulder pad anim, instead of being constrained to the joint itself, it's constrained to a set of offset groups. So I do have this first offset group for my joint, but I also have another offset group which takes the input from the shoulder joint anim. Or the shoulder pad anim, sorry. So this anim is driving this offset group, and this offset group takes the information that we need to counter the animation between these guys. You'll also notice that this anim is sort of offset from the rest of it. While it's a visual error, it shouldn't impact the rotation of this being consistent. Cool. So just to go everything, when we move this, it moves up. When we move the shoulder, when we move the arm, the shoulder pad rotates with it upward as expected. When the shoulder pad is rotated upward first, the arm will not affect the shoulder pad until it hits it. The animator can then zero this out when they feel the time is right, and everything will go back to normal. Without this functionality, for example on the other side, it does not have this functionality yet, which we will set up in just a moment. You'll notice that when we move it up, it keeps the offset. It has the first part of it set up, just these 3 or 4 nodes, but it does not have all this other stuff underneath it in order to create the compensation that we want. So it starts immediately rotating it when we move upward. Creating this automatic setup can eliminate some of the time that is needed from an animator's standpoint. Because we use the skin up arm joint as a reference, instead of, for example, this anim, we can go to our IK mode, and the functionality should still work. Keep in mind that this character is a little unique, wherein his arm rotates or translates upward when he's moving. This function is specific to this rig, but if you just wanted to use the shoulder pad anim for your own rig, it should work exactly the same, because this works on a different set of... Alright, it's time to set it up, and I've set up 2 of my first input nodes for my node editor. I haven't been able to set up these ones yet, because I wanted to double check in my outliner that I have the same setup as the other one. So, I know that I need to make this offset group that we were talking about earlier. Now there's 2 offset groups, and one of them is controlled by the parent constraint from the shoulder pad. So, I can go to my joint, let's group it, and make sure that my pivot is in the right spot. Using modify match pivots. Alright, now I can group it again and do the same function. I press G to do the same exact function. And it's very important that these 2 groups are zeroed out. So, to use the same naming conventions as the other guys, let's grab this one and bring it over here. Change it to R. Change this one to 2 and to R. Oh, goodness gracious. I put it on the joint and not the group. Okay, let's put this here. Alright, so I have the same setup that's going on here. And I already noticed immediately that my parent constraint is currently in the wrong spot because it was previously in the correct spot. But since we're adding these offset groups, we have to change it up a little bit. So I took my shoulder pad in. I take my second offset group. And then I can go to constrain parent and make sure that everything is all good. Alright, now it looks like we got everything good. This guy should be rotating him, and she should also be able to be rotated by his first offset group. With that all set up, oh, that's what is all this happening? Clean up my node graph. Don't need this guy. Mimicking the setup from over here, it looks like I'll need the shoulder pad in. And I'll also need my first offset group. Looks like I'll also need my constraint group from my shoulder pad in. Just to double check, it looks like I already have an input rotate Z on here. So I'll make a new thing, new page, and I'll go here. This is the condition for the original setup that doesn't account for if the thing is already rotated. So for now, I can go ahead and bring this up arm anim in here, as well as these two nodes, so I can see what's going on. This was from the original setup, where I used the anim and not the skin joint to drive the rotation conditions. So I can go ahead, take note of my input Z. Looks like I used rotate Z. So I'll go to my skin up arm joint, take my rotate Z, and plug it in here instead. In the case that you didn't already have it, I take my rotate Z, I plug it into multiply divide node, I checked it, multiplied it by -1 to flip the sign, took my condition, I made it the color if true R in the first term input, and it's less than or equal to. In the one above here, I used the greater than or equal to without the use of a multiply divide node. Either way works, but if you wanted for the sake of cleaning up your node editor, you can just remove it, and we can mimic it from up here. Similarly, it also used rotate Z and plugged it into the color if true R and first term. Color if true R and first term. And since I used greater than or equal to, let's just plug it in here. So now everything should be similar. As we continue, I'll make sure that I'm zeroing these out, so in case any data doesn't get passed over. Alright. Looks like I got an output R to a multiply divide node. Using the same operation and inputs, I'll set it to multiply. It looks like I'm multiplying it by -1 to flip the sign. Because I did it before, but now I'm having it after. Oh, since I put it in input Z, I'll need to put it in the input Z here. I'll use my output Z to go into my rotate Z. now I have the same setup, but I have my multiply divide node set up after. Either way works, but for the sake of keeping consistency for the plus minus average node, I'll want to make sure I use this setup, where the condition is greater than or equal to, where the first term is my rotate z from the skin up arm joint, reading the rotation upwards. By default, often condition nodes will have the color if false set to 1, so make sure you have those set to 0, or else you'll have a permanent 1 rotation on your joint, on your constraint group. Alright, so now that we have the original setup cleaned up and ready to go, I'll start making my conditions for the rotation compensation here. So, I'll use the multiply divide node with my input z minus 1 multiplied by. Rotate z into input 1z, and for my input 2z, I'll use negative 1 to flip the sign. Now, I'll create another condition with the greater than or equal to operation. Like I mentioned earlier, the condition if false is set to 1, so I'll set it to 0. If it's true, I want the R to be equal to the output that I just made. So I'll put my Z into R in first term. This gives us the same setup as the other one. Alright. Let's create our plus minus average node, which will be taking the inputs from our two condition nodes. I want to use operation subtract. And then input 1D, I'll take my first condition's output R. And for input 1D1, I'll take the output R from our other condition. This will be subtracting. Then, I'll finally be able to create my last condition. I'm setting the false to 0. It's similar to the other condition nodes we've made. Our color if true R will be the output from our plus minus average. And our first term and second term will be our respective conditions. So our first term from the OG, and our second term from the second one. Then, if everything went correctly, we should be able to use our output R to our rotate Z. An easy one to miss is the conditions. We want to make sure that it's set to less or equal, and this one is set to greater than or equal to, as well as these two as well. So we should have greater than or equal to and less than or equal to on these ones. Now we have our shoulder pad all set up. So if you have a character with shoulder pads, keep this in mind for your next rig.